The rotational motion, we got it. The moment of inertia with different bodies, we got, isn't it?
Sir,
Yes, sir. Tell
sir,
me,
I have
Rishi.
doubt in question number 79 of HC Verma rotation.
Okay, I'll do it. Okay, I'll do it, sir.
Okay.
79.
Yes, sir.
Sure. Okay, I'll do it. Don't worry. So now what we are going to do, we'll move on to your the thermodynamics part. So to start the thermodynamics, first we will do the kinetic theory of gases. Okay, the kinetic theory of gases that we need to do. Then you will get the concept, and according after that, there's a continuation part, thermodynamics with that. Now, already you know that in gas, the molecules are moving randomly from one place to another place, and in gas there is no particular shape or size, and volume is the volume occupied by the gas, means that is the volume of the container. Okay, that is the volume occupied by the gas. So there are certain basic postulates on the kinetic theory of gases because molecules are moving randomly. I'll just tell you, okay, you need to remember it. Any book, you will find it out. The basic postulates of kinetic theory of gases. Okay, the among the postulates, that is your, the all molecules of gas are identical and very small in size. Identical. So molecules are identical and very small in size. What it means actually? It means actually the volume of the molecules are negligible as compared to the volume occupied by the gas. Understood? So that means whatever the volume occupied by the gas, okay, is actually the volume of the gas, because we are taking it, the size of the molecules are negligible. So total volume of the molecules is negligible as compared to the volume occupied by the gas. So basically that means the volume of the container is the volume of the gas. Then second one, there is no force acts between the molecules. Okay, there is no intermolecular force of attraction among the molecules. There is no intermolecular force of attraction among the molecules. Okay,
Sir, आज की
and they move.
discuss करा हो.
Yes, just I started the kinetic theory of gases. As I told you, it's a starting for the thermodynamics part. So the molecules are moving randomly, okay, along a straight line with constant speed. But there is no intermolecular force of attraction. That is negligible, we say. Okay. All right. Then the collision between the two molecules is perfectly elastic. That means the kinetic energy remains what? Conserved. Because elastic collision, you know. So the collision between the two molecules is perfectly elastic. That means the total kinetic energy of the gas molecules is
Trial version.
always conserved.
Trial version.
Next one. The time
Trial
for
version.
collision is negligible as compared to the,
Trial version.
okay, again I am telling you, the time
Trial version.
of collision is negligible as compared to the time
Trial
spent by
version.
the molecules between two successive collisions.
Trial
The
version.
time of collision is negligible, means when they are colliding, that is for a fraction of
Trial version.
seconds as compared to the time between the two successive collisions. Means
Trial version.
one molecule collide and then again what happens, it moves randomly,
Trial
then
version.
again second collision takes place. Now this is the time interval between the two
Trial version.
successive collisions is much more as compared to the
Trial version.
time during the collision. Okay,
Trial version.
and remember it, the distance
Trial version.
traveled by the molecules between two successive collisions is
Trial version.
called, anyone knows, the distance traveled by the
Trial version.
molecules between two successive collisions is called what?
Trial version. Trial version.
Is called
The time period.
Trial version.
tell.
Trial version.
The distance traveled by the molecules between two
Trial
successive
version.
collisions is called what? Do you know?
It's a free mean path.
Trial version.
Mean free path. Mean free path. Perfect. So mean free
Trial version.
path. Okay.
Trial version.
Now you know the basic, the the equations.
Trial version.
Sir,
That is your yes, sir. Tell me.
sir, can you just explain me the time law once
Trial
more?
version.
Okay. Means time during the
Trial version.
collision is negligible as compared to the time between the two successive
Trial version.
collisions. Means when the two molecules colliding, that is your instantaneous.
Trial
That time
version.
is negligible as compared to the time interval between the two
Trial
successive
version.
collisions. Are you getting it? Means a molecule collide with one molecule,
Trial
then again it
version.
moves randomly, again collision taking place. This time interval means time between the
Trial
two
version.
successive collisions is much more as compared to the time during the collision.
Trial version.
Is it clear?
Yes, sir. Yes, sir.
স্যার
Uh,
Trial version.
পাত্রটা
yes.
এক্সেলের মধ্যে লেখা নেই, আমরা কি নোট ডাউন করে লিখবো?
হ্যাঁ হ্যাঁ লিখে নাও।
Trial version.
ওকে, এগুলো সব বইয়ে পাবে এগুলো। These are the basic postulates, okay, of
Trial
kinetic
version.
theory. Even in chemistry also you'll find it out. And you know that we are
Trial
dealing with
version.
your ideal gas over here. Remember it. So if your ideal
version.
gas, then PV equals to your what? Mu RT,
Trial
isn't
version.
it? What is the ideal gas equation? PV equals to mu RT,
Trial
or
version.
some book it is written nRT also, no problem. So PV equals
Trial
to
version.
mu RT or nRT, anything you can write, but that is small n.
Trial
Remember it, but
version.
we don't write, generally we write mu RT. It's easier actually. I'll tell you why.
Trial version.
So PV equals to mu RT. What is the value of R?
Trial version.
What is the value of R?
0.0821.
Trial version.
R is
0.
8.3 in
Trial version.
1 joule per mole per Kelvin. Remember it, capital R, absolute gas
Trial
constant.
version.
Absolute gas constant value is
Trial version.
8.3, okay,
Trial version.
joule per
Trial
mole
version. Trial version.
per Kelvin.
Trial
joule
version.
per mole per Kelvin. Okay,
Trial
8.31
version.
actually joule per mole per
Trial version.
Kelvin. This is very important value. Otherwise, your answer will not
Trial
match.
version.
Can anyone tell me how you are getting it, sir?
Trial version.
Sir, PV by NT.
Yes, the mu
Trial version.
PV equals to mu RT, isn't it? So R equals to what? PV by mu
Trial
into
version.
T. Now P is the normal atmospheric pressure. That is your what?
Trial version.
1.013 into 10 to the power 5 Pascal. P volume.
Trial
What is
version.
the volume occupied by the gas? 1 gram mole gas.
Trial version.
Yes, sir.
How much volume?
22.4 liters.
Trial
Perfect.
22.4.
version.
22 by Avogadro's law. 22.4 liter to meter cube. SI
Trial
system.
version.
So 22.4 into 10 to the power minus 3 meter cube. Is it okay?
Trial version.
Yes, sir.
By mu 1 mole into
Trial
temperature
version.
Kelvin 0 degree centigrade. Normal temperature and pressure 0 degree centigrade means
Trial
273.
version.
So into 273. So now you see that how much are you getting it, the value you
Trial
see.
version.
1.013 into 10 to the power 5. That is your pressure, Pascal.
Trial
Volume
version.
22.4 liter means 22.4 into 10 to the power minus 3
Trial
meter
version.
cube. Then next one is your mu
Trial
1 mole
version.
and temperature, normal temperature, that
Trial
is your
version.
0 degree centigrade means 273 K. So into 273. So find
Trial
it out, you
version.
will find 8.31. You'll get it joule per mole per Kelvin.
Trial
Okay.
version.
Sir, sometimes we write 0.0821. Sir, is that for
Trial
calorie?
version.
Hmm.
Trial version. Trial version.
Okay. So everywhere in your, because we
Trial
have done
version.
everything in SI units, so everywhere in physics you will take 8.31 joule per mole per
Trial version.
Kelvin, sir. This. The next is very important. I will
Trial
not go
version.
ahead with the derivations actually, no need unnecessary wastage of time.
Trial version.
As the molecules are moving randomly, okay, just follow me.
Trial version.
As the molecules are moving randomly, so
Trial
they
version.
collide with the walls of the molecules, sorry, walls of the
Trial version.
container. Okay, again they return back, and over here the total kinetic energy
Trial
remains
version.
constant. So they exert pressure
Trial version.
on the walls of the container. Are you getting it?
Trial version.
A molecule is moving randomly. So what is the velocity
Trial
actually? So
version.
it will be your 3 dimensions, no? So that means v square will be your what? Vx square
Trial
plus vy
version.
square plus vz square. So in any along x-axis, suppose it is
Trial
moving with a
version.
velocity vx. So what is the momentum
Trial
of
version.
that particular molecule along x-axis? M into vx. Now, as it's a
Trial
perfectly
version.
elastic collision, so it will return back with the what velocity, sir?
Trial version.
Who can tell me? As at the basic, at the
Velocity.
beginning,
Trial version.
yes, at the beginning I told you the collision between the molecules
Trial
is
version.
and the walls is perfectly elastic, or among the molecules
Trial
also.
version.
So that means it will return back with minus Vx. Okay, due to the
Trial
collision
version.
with the walls. So that means while returning, what is the momentum? Minus Vx.
Trial version.
So what is the then change in momentum, sir? Vx minus of minus Vx.
Trial
That
version.
means 2Vx is the change in momentum. Twice m into Vx.
Trial version.
Any problem?
No, sir. Sir, are you writing
Trial
something?
version.
No. Just I'm telling you actually, you don't need basically this proof.
I can.
Understood?
Trial version.
Okay, 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 sir.
No. Okay. So
version.
now one more thing, suppose in a container it has kept and the
Trial version.
it's in a cube box of side suppose
Trial
L.
version.
So during the collision, after colliding one, then
Trial
again
version.
next wall it will collide, opposite wall. So what is the
Trial
distance
version.
traveled? 2L. Am I right?
Trial
Yes,
version.
sir.
Is distance between the two successive collisions. So 2L. So what
Trial
is the
version.
time interval, sir? 2L by speed, distance by speed. So
Trial
2L by
version.
Vx is the time interval between two
Trial version.
successive collisions. Okay. All right.
Trial version.
Yes, sir.
So using this, then if I finding out what is the momentum for in 1 second,
version.
momentum change in 1 second, that we can find out the change in momentum 2 mvx
Trial version.
by 2l by vx. So m into vx square by l,
Trial version.
or m by l into vx square. So this is for one. Similarly for second also same, third also
Trial
same along
version.
x-axis. So similarly y-axis same, then vy, and z-axis vz.
Trial
Then if
version.
I take it that average, so by 3. So using
Trial
this,
version.
if I go ahead with that, the total pressure
Trial
exerted,
version.
because pressure is your what? The rate of change of momentum, that is force
Trial
by the
version.
area. So the pressure exerted
Trial version.
will be your the P equals to,
Trial version.
remember the main part which is required.
Trial version.
So pressure exerted by the gas or on the walls of the
Trial version.
container is
Trial version. Trial version.
so P equals to write down now.
Trial version.
So pressure exerted by the gas P equals to
Trial
1
version.
by 3 rho into
Trial version.
C square. There I am telling you what are these are the terms.
Trial version.
P equals to 1 by 3 rho
Trial
into
version.
C square.
স্যার
Hmm.
স্যার এটা কি কালিচুরি
Trial
চ্যাপ্টারটাই
version.
এটা কি
পড়াচ্ছে?
গ্যাসের ভেলোসিটি?
আমি বলছি এটা না না না,
Trial
this is
version.
actually the kinetic theory of gases, thermodynamics going.
এই স্যার সিটা কি গ্যাসের ভেলোসিটি?
Trial version.
I'm coming. So pressure exerted by the gas P equals to
Trial
1
version.
by 3 rho into C square. Rho is the density of
version.
gas.
Trial version.
And C is called
Trial version.
Velocity of light.
root. Yes, this is the
root
velocity
mean
of the
square
gas
velocity.
molecule. Root mean square velocity,
Trial version.
RMS velocity.
স্যার এটা তো
Trial
কেমিস্ট্রি
version.
স্টেটস অফ ম্যাটার ইকুয়েশন থেকে ডিরাইভ করা। PV ইকুয়ালস টু 1/3 mn c স্কয়ার।
এটা
Trial
এখানে
version.
প্রুফ পাবে, কেমিস্ট্রিতেও প্রুফ করবে দেখবে তোমাদের।
স্যার কেমিস্ট্রিতে
Trial version.
So P equals to 1 by 3 rho into
version.
C square. C is the RMS velocity. Now what is RMS velocity? See over here.
Trial version.
Now all the gas molecules are moving randomly with all
Trial
possible
version.
velocities ranging from 0 to infinity. So which velocity will you take as the
Trial
velocity
version.
of the gas? Because a gas contains millions of gas molecules, isn't it? So which velocity will
version.
you take it as the velocity of the gas? So for that, what we do
Trial version.
basically, velocity is a vector quantity. So we take
Trial version.
the square of this, means v1 square plus v2
Trial
square
version.
plus so on, vn square, so there are n number of
Trial
molecules
version.
by n. by the number of molecules. This is got it to what?
Trial
Average of the
version.
square of the velocities, and if I take the root,
Trial version.
this is called RMS velocity. CRMS or
Trial version.
VRMS sometimes they write, some people write RMS also suffix. So but it's
Trial
easy to
version.
write C only. C means RMS. This is the RMS velocity. Sir. Root means square.
Trial
Root
version.
means square. First we make the square of the velocities, then we take
Trial
it the
version.
mean. So add and divide by the how many? Number of molecules. Then
Trial
we
version.
take the root. Then automatically you get the velocity, sir. So this is called root mean
Trial
square
version.
velocity. Is it
Sir,
okay? Hmm.
because there are
Trial
infinite
version.
gas molecules with different velocities, that's why we are.
Different velocities. That's why we take
Trial
this is
version.
the actually the velocity. There are different velocities. You'll find it out. But
Trial
in
version.
it has been observed that if you take the RMS velocities, the behavior
Trial
we get it
version.
to a perfect. Like there is another one, the mean velocity also. Okay, or
Trial
average
version.
velocity. Then another velocity is their most probable velocity.
Trial
Okay,
version.
there are three types of velocity. One is called mean or average velocity. Second
Trial
one is
version.
the RMS velocity. I mean just normal, add and divide by the number of
Trial
molecules. And
version.
third one is most probable velocity. Okay, so
The
Trial
and
most probable
version.
each
velocityটা তো যেটা সবচেয়ে ম্যাক্সিমাম নাম্বার অফ মলিকিউলস এর যে ভেলোসিটিটা থাকে।
that which
Trial version.
can be okay, that is called most probable velocity. So these
Trial
all having
version.
the different expressions. Later on you will find it out in physics only, you will be
Trial
studying
version.
it. Now next we will deal with the different
Trial version.
expressions. So P equals to, I got 1 by 3 rho c square. Rho is the
Trial
density.
version.
Density can I write m by v.
Trial version.
So P equals to 1 by 3
Trial version.
m by v into c square. Is it okay?
Trial version. Trial version.
M is the mass of the gas. Any problem?
Trial version.
No, sir.
Is there any problem?
Trial
Now
version.
this I can write another way also. 1 by 3
Trial version.
small m into small n
Trial version.
by v into c square.
Trial version.
What is small m and small n?
Trial version. Trial version.
Huh?
Trial
The
version.
Small m
small
is the
n,
mass of each molecule.
the small n
The
is the
mass.
number
Trial
of
version.
moles.
Number of molecules, sir. Small n is the number
version.
of, small m is the mass of each molecule.
Trial version.
Because all gas molecules are identical.
Trial version.
Each molecule, and small n
Trial version.
is the number of molecules.
Trial version.
So if small m is the mass of each molecule
Trial version.
and small n is the number of molecules, so automatically m into n is the total mass of the gas.
Trial version.
Yes or no? Is it okay?
Trial version.
M into n will be what? The mass of the gas, the total mass
Trial
of the
version.
gas. Any doubt?
Trial
Tell me.
version. Trial version.
Any problem?
Trial version. Trial version.
Any problem?
No, sir.
Trial version.
Good.
Trial version.
Next, you see
Trial version.
that these are the different expressions, sir.
Trial version.
Okay. Now from here, we can deal with your
Trial
some
version.
other expressions also. That means C equals root over of, I can
Trial
write it
version.
down, C, the RMS velocity root over of 3p by rho from here only.
Trial version.
C will be over root over of 3p by rho. Automatically you can
Trial
find it
version.
out. That is
Trial version.
any problem.
Trial version.
Now you know the kinetic theory of means before that
Trial
in
version.
your the gas equation PV equals to, that is why we write mu
Trial version.
RT, because otherwise it will, if I give this n, then it
Trial
will mix with this n actually. Okay, that's why we write a mu
Trial
is
version.
the number of moles. All right.
Trial
Now
version.
next you see from here PV equals to, if I do the
Trial version.
calculation, PV equals to your what? 1 by 3
Trial version.
m into c square. PV equals to 1 by 3
Trial
m
version.
into c square. Is it okay?
Trial
Now if
version.
you take 1
Yes.
mole of gas, if you
Trial
take
version.
1 mole of gas, means mu equals to 1 suppose. Any problem over here?
Trial version.
No, sir.
Now if you take 1
Trial
mole
version.
of gas, that means small n will become your capital N or Na Avogadro's number.
Trial version.
Is it okay? So PV equals to then what?
Trial version.
RT. RT will be a what? So mu is 1. 1
Trial
by
version.
3 small m into capital N if we want.
Trial version.
Capital N is the Avogadro's number because 1 mole I have taken it.
Trial version.
So that means
Trial version.
ক্যাপিটাল এমটা তো মলিকুলার মাস ছিল
কোনটা ক্যাপিটাল, হ্যাঁ
Trial
সেটা
version.
হচ্ছে m, mass of each molecule into the number of molecules.
আচ্ছা স্যার
If you take 1
Trial
mole,
version.
so then number of molecules will be a what? Avogadro's number. Is it okay?
Trial version.
ইয়েস স্যার
So that means from here you can define the
Trial
expressions what
version.
I am writing it, you don't know in the numerical what values to be provided. So C will be over
Trial
root
version.
over of 3 RT
By M.
Trial version.
M. Now from
Trial
here, this is
version.
a very important expression. For a given gas, okay,
Trial version.
M is fixed. Am I right? Capital M is fixed,
Trial version.
R is fixed. So M is fixed, R is fixed.
Trial version.
That means what I can write is C proportional to root over of.
Trial version.
This is very important.
Trial
C
version.
Okay, sir.
for a given gas, for a given gas. Understood?
Trial version.
Is it okay?
Trial version.
স্যার এখানে ক্যাপিটাল এনটা
Yes, sir.
Capital M,
Trial version.
total
Sir,
mass of
capital
the
N.
gas, molar mass. Capital N.
এন
Trial
Avogadro's
version.
number.
Trial version.
Isn't it? I've taken 1 mole of gas, mu is 1, so small n will become
Trial
your what?
version.
Then capital N. 1 mole
Trial
of gas
version.
is how many number of molecules? Avogadro's number.
Trial version.
Any problem?
Trial version.
No, sir.
Then next we'll find it
Trial
out the
version.
kinetic energy of one molecule. Okay. The next
Trial
from
version.
here we are going to find out the kinetic energy.
Trial version.
Energy per molecule.
Trial version. Trial
Kinetic
version.
energy per molecule of the gas. Just see it.
Trial version.
K equals to your what, sir?
Trial version.
Half
half mu square.
m into c square.
Trial version.
Yes or no?
Yes, sir.
Any
Trial
problem?
version.
So that is equals to
Trial
half
version.
m into c is what, root over 3 RT by
Trial
m.
version.
Yes or no? That means
Trial
3
version.
RT by capital M
Trial version.
is the kinetic energy
Trial
that
version.
gives you 3 by 2 RT.
Trial version.
এটা থেকেই তো বার করে দিতে পারি 3/2 পিভিও হয়ে যাচ্ছে
Trial version.
Now you see per molecule. So K per molecule,
Trial
1 mole
version.
you have taken it. 1 mole you have taken it. So in 1 mole, how many number of molecules are
Trial
there?
version.
Avogadro's number. That is equals to
Trial version.
3 by 2 RT by N
Trial version.
or Na. Am I right?
Trial version. Trial version.
Any problem?
Trial version.
Any doubt?
Trial version.
Now R is constant, N is constant. So R by N
Trial
is will
version.
also be a constant. That is equals to 3 by 2
Trial version.
KT, small k T. K is called Boltzmann
Trial
constant.
version.
Very important. So K is called Boltzmann.
Trial
B O
version.
L T Z M A
Trial version.
double N. Boltzmann's constant.
Trial version.
R you know and N
Sir,
you
it is
know.
not visible.
Trial
Could you
version.
please shift the camera a little bit down?
Is it okay?
Trial version.
No, sir, I couldn't see the Boltzmann constant.
Oh,
Trial version.
this Boltzma double N.
Trial version.
Okay, did you see it?
Trial version.
No, it is okay.
Yes, sir.
So Boltzmann
Trial
constant, sir.
version.
R by N.
Trial version.
R is the absolute gas constant and
Trial
N,
version.
so R by N is also a constant. This is called Boltzmann
Trial
constant.
version.
Now from here you can say that you can prove the Boyle's law, Charles'
version.
law and Avogadro's law. Now Boyle's law you are getting it from here only.
Trial
PV
version.
equals to 1 by 3 mnc square. Now if temperature is constant, so from here what I conclusion I can
Trial
say
version.
the C is a function of what? Temperature only. C is a function of what? Temperature
Trial
only.
version.
If temperature remains constant, that means PV equals to constant. That
Trial
means
version.
this is the Boyle's law. Is it okay? If
Trial
temperature is
version.
constant, that means PV equals to constant. This is Boyle's law.
Trial version.
Now Charles' law, C proportional to root T.
Trial version.
So C square proportional to T, that means V proportional to
version.
T. That is your Charles' law.
Trial
Is it
version.
okay?
Yes, sir.
Trial
And
version.
Avogadro's law, I'll prove it, sir. That is very important.
Trial version. Trial version.
Sir, sir, what did the Avogadro law state? V directly proportional to N.
No, Avogadro's law said what? Under the same condition of temperature and
version.
pressure, equal volume of all gases contains equal number of molecules.
Trial
Isn't it?
version.
Hmm?
Oh, molecule. Oh,
So under
yes,
the
sir.
same
Trial version.
condition of temperature and pressure equal, so gas 1,
Trial version.
this is gas 2 suppose. Under the same condition of temperature and pressure,
Trial version.
temperature T, same temperature, pressure P,
Trial version.
equal volume of all gases, volume is suppose V,
Trial version.
contains equal number of molecules. Suppose that do not
Trial
contains
version.
equal number of molecules. Suppose this is N1, this is N2.
Trial version.
And as the gases are two different gases, so their masses will be also, for each
Trial
molecule
version.
masses will be also different. Suppose this is mass is your, each molecule is
Trial
M1,
version.
and for second gas for each molecule mass is M2. Is
Trial
it
version.
okay? Again, you see under the same condition of
Trial version.
temperature and pressure. So temperature, pressure, that's why same equal volume. That's why VB also
Trial
same.
version.
Equal volume of all gases contains equal number of molecules.
Trial
So I have
version.
taken the number of molecules are different. One is N1, other one is N2. So basically I have to find it
Trial
out
version.
or prove N1 equals to N2. Now I have
Trial
taken if the
version.
mass of each molecule is different because two gases are different, sir. So first gas is
Trial
mass of
version.
each molecule is M1, second gas mass of each molecule is M2, sir.
Trial version.
Is it clear for everyone? Any problem?
Trial version.
No, sir.
No. So now what will be the same as the pressure is
Trial
same, then
version.
what I can write it down. So P equals to same. What is the expression, sir, for
Trial
pressure?
version.
1 by 3 mnc square.
Trial version.
And for second gas, again same
Trial
thing.
version. Trial version.
Is it okay?
Trial version.
Any
Yes,
problem?
Trial version.
Hmm?
Sir,
Yes, sir.
Trial version.
sir, C is only proportional to T, so will
Fruity.
C1 not
Trial
equal to
version.
C2?
No, direct proportional though.
Trial
It's a
version.
proportional though. They are the two different gases.
Yes, sir.
Trial version.
So C is directly proportional to T though. But
Yes,
not
sir.
Trial
It
equal
version.
though.
only depends upon T, so temperature is fine.
Temperature, yes, but
Trial
it's not
version.
as if the temperature is same, okay, but that doesn't mean
Trial
the C
version.
will be same because there are other parameter also. C equals to a root over of 3
Trial
RT by
version.
M, na? C
Acha,
directly
yes, sir.
proportional to
Trial
T
version.
for a given gas. That time only, that's why I told you. Is it okay?
Trial
Yes, sir. Yes,
version.
sir.
But these two are two different gases, sir. So I cannot say C will be different, it's
Trial
the same,
version.
C1 equals to C2. Because these two are different gases, sir. Are you getting it, the concept?
Trial
Yes,
version.
sir.
When I wrote C proportional to root T, you see, I
Trial
took it
version.
same M.
Yes, sir.
Molar masses are same.
Trial version.
Okay, sir.
But over here, two different gases. So that's why I told you at this
Trial
beginning,
version.
that time only for a given gas,
Trial version.
Okay, sir.
Now, one very important, now
Trial
as the
version.
temperature same, when you said, let me tell you, what will be same for both the
Trial
gases?
version.
The
Trial
temperature
version.
same. The product of
Hmm?
pressure and volume will be same.
At
স্যার
the
এখানে যদি
temperature,
Trial version.
সাবস্টিটিউট করি তাহলে তো ওই M1টা ক্যান্সেল আউট হয়ে যাচ্ছে, M2টাও ক্যান্সেল আউট হয়ে যাচ্ছে।
Trial version.
কোনটা?
যদি আমরা লিখি সি স্কোয়ারের ভ্যালুটা মানে C1 স্কোয়ারের ভ্যালুটা লিখি 3RT বাই
Trial version.
By
M1N,
M1, হ্যাঁ,
Trial
তাহলে তো
version.
ওটা তো
অ্যাভোগাড্রো,
M1 N2 তো আমাকে দেখাতে হবে তো সেম।
না M1, তাহলে M1
Trial
M1
version.
ক্যান্সেল আউট হয়ে যাচ্ছে, তাহলে N1 ইকুয়ালস N2 হয়ে যাচ্ছে।
Now, what we
Trial.
can do over here, you see another way, as the
Trial
temperature
version.
same, see my expression. what will happen, sir?
Trial version.
They will move with the same speed.
Same
Trial
kinetic
version.
energy per molecule will be same. Am I right?
Yes, sir. Speed
Just
will
check
be
it out.
same for kinetic energy.
Trial
Kinetic
version.
energy per molecule is same. Is it okay?
Trial version.
Yes, sir.
Am I right?
Trial version.
So as the temperature same, so kinetic
version.
energy per molecule is same, because kinetic energy per molecule is 3/2
Trial version.
kb into T or kT. So I can write it
Trial
down
version.
as temperature same,
Trial version. Trial version.
hence kinetic
Trial
energy
version.
per molecule Ke per molecule is
Trial
same,
version.
for both
Trial
the
version.
gases. As the temperature is same, so kinetic
Trial
energy
version.
per molecule is same for both the gases.
Trial version.
Is it okay?
Trial version. Trial version.
Is there any
Trial
problem?
version.
No, sir.
Trial version.
Good. So kinetic energy per molecule is same. Hence, I can write it down.
Trial version.
That means half first gas
Trial version.
M1C1 square.
Trial version.
Is it okay?
Trial version.
Is it okay?
Trial version.
Per molecule, each molecule. First gas, each molecule, what is the kinetic energy? Half mass of the each
Trial
molecule
version.
into speed C1 square. For second, because they are all equals to
Trial version.
3/2 K T.
Trial version.
Is it okay?
Trial version.
Yes, sir.
Now, as both are pressure, so you can
Trial
equate these
version.
two. Another one, and or from here you can write
Trial version.
M1C1 square equals to M2C2
Trial
square.
version.
And pressure you can equate this 1/3
Trial version.
M1 N1 C1 square equals to
Trial
1/3
version.
M2 N2 C2 square. So hence I can
Trial
write
version.
M1 N1 C1 square equals to M2
Trial version.
N2 C2 square. This is equation 2.
Trial version.
I equated both the pressure same.
Trial version.
Yes,
Trial
sir.
version.
Now what you do? You do 2/1.
Trial version. Trial version.
If I write equation 2/1, then what are you getting it?
Trial version.
N1 equals to N2.
Yes. Then N1 equals to
Trial version.
N2, sir. Okay.
Trial version. Trial version.
স্যার এটাই অ্যাভোগাড্রো বলেছিল।
Trial version.
Yes. So got the proof.
Trial
Okay.
version.
ওকে।
Trial version.
স্যার
Is it okay?
Trial version.
স্যার
Yes, sir.
এখানে কাইনেটিক
Trial
এনার্জি
version.
পার মলিকিউল বলেছে 3/2 RT/N।
हाँ মানে kb r/n
Trial
Avogadro's
version.
number is called kb তো Boltzmann constant তো
হ্যাঁ স্যার তা বলছি
Trial
না,
version.
মানে এনটা ওখানে আনা হয়েছে ইসের মানে
Avogadro's numbers.
মলিকিউলের জন্য, অ্যাভোগাড্রো নাম্বারের জন্য।
Trial version.
Okay, sir.
the constant.
Trial version.
Okay.
Yes, sir.
So
Trial version.
now we got it this. Now next term, I'll tell you
Trial version.
degree of freedom. Write down, all of you, write down
Trial version.
degree of freedom.
Trial version.
Sir,
Okay.
is this degree
Trial
of freedom
version.
dependent on the gives free energy? Something like that.
Yes.
Trial
So
version.
degree of freedom, very important term. Why? Because this I require
Trial
it later
version.
on. You will see it in thermodynamics only. That's why actually I started this chapter.
Trial
So
version.
degree of freedom, write down. It is the
Trial version.
number of
Trial version. Trial
independent,
version.
So can we reply? Right. Yes.
yes, it is
Trial
the
version.
number of independent
Trial version.
coordinates
Trial version.
required
Trial version.
to specify
Trial version.
the
Trial
position
version.
or
Trial version.
configuration
Trial version.
of a
Trial version.
dynamical
Trial version.
system. It is the number of independent coordinates
Trial
required
version.
to specify the position or
Trial
configuration
version.
in a dynamical system. Is it okay?
Trial version.
This is called dig. Now I'll explain it. Don't worry. Very
Trial version.
important term. We need thermodynamics every time.
Trial version.
Saurajit, understood. Sujatro,
Trial version.
Warner.
Yes,
Trial
understood.
version.
Okay. Now I'll tell you what is that. Suppose you
Trial
have
version.
monoatomic gas. So what is the degree of
Trial
freedom
version.
for monoatomic gas?
Trial version. Trial version.
What is the degree of freedom for
Trial version.
monoatomic gas?
Sir, 1.
Sir, one.
1.
Trial version.
Okay. Rajdeep Lahiri,
Trial version. Trial
Lahiri,
version.
Sir, 3.
3 you are saying.
Trial
Nandika,
version. Trial version.
Nandika,
Trial version.
no answer.
I think
Mominur,
Trial version.
3. So number of, so
So
degree of
X, Y,
freedom
Z.
is, yes,
Trial
because
version.
you have a monoatomic gas. So the particle is a single particle. So to
Trial
specify
version.
its position or configuration, how many coordinates are required?
Trial version.
How many coordinates are required? A single particle,
Trial version.
3, sir.
3, x comma y comma z. So 3 coordinates are
Trial
required.
version.
So to specify a monoatomic gas, that means for monoatomic gas, the degree of
Trial
freedom
version.
is 3. Is it okay? For monoatomic gas, the degree of
Trial
freedom
version.
is 3. Is it okay? Understood?
Trial version.
Any
So
problem?
only for
Anyone having any
monoatomic gas,
problem?
not
Tell
all
me.
gases.
Yes?
Trial version.
So only monoatomic gas or
This
all
is for
gases?
monoatomic. I'm coming, sir.
Trial
Everything I'm
version.
coming, sir. I'm coming. So this is so helium. You need to do, because why?
Trial
Because we'll be
version.
dealing with different types of gases in thermodynamics. That time you need this.
Trial
So
version.
degree of freedom equals to, so 3. For monoatomic gas, the
Trial
DOF
version.
equals to 3. So for monoatomic gas, degree of freedom is equals to
Trial
3.
version.
Next I'm coming diatomic gases. How many
Trial version.
coordinates are, how many degree of freedom?
Sir, 6.
6.
Trial version.
Okay. Dibbajyoti,
Trial version.
Sir,
Monoshini.
sir, can you once repeat the question?
Trial version.
Sir, 9.
For diatomic gases, how many
Sir,
degree of
9.
freedom are there?
Trial version.
Sir,
9.
9.
Okay.
Trial
So for
version.
diatomic gases, the degree of freedom is
Trial version.
9.
স্যার কেন স্যার একবার বলুন?
So
Trial version.
so so for diatomic gases, the degree of freedom is 5,
Trial version.
not 9 or not
6, sir?
6.
5.
Trial
5,
version.
5, sir. See it, what happens. For diatomic gases, the degree
Trial
of
version.
freedom is 5. Now, what was my definition of degree
Trial
of freedom,
version.
sir? Number of independent coordinates required
Trial
to
version.
specify the position or contain. Number of independent coordinates.
Trial version.
You have a diatomic, hydrogen, helium. They are
Trial version.
bound together. Am I right, sir?
Trial version.
Am I right? They are bound together.
Trial
Sir.
version.
So to specify these 3 coordinates x1,
Trial
y1,
version.
z1. For these 3, x2,
Trial
y2,
version.
z2. But what happened? Then the 3 plus 3, 6 should be.
Trial
But
version.
why I said 5? Now that distance is fixed among themselves.
Trial version.
Distance is fixed among themselves.
Trial version.
Am I right, sir?
Trial version.
Any
Trial
problem?
version.
So if the
Sir,
distance
can you
is
repeat that?
fixed,
Trial
Why not
version.
6?
I'm coming. So for this molecule, 3, for
Trial
this
version.
3. So 3, 3, 6 so should be. But I told you 5. Why, sir? I'm explaining me.
Trial
Now as the
version.
distance is fixed, then what I can write it down? x2 minus x1
Trial
whole
version.
square plus y2 minus y1 whole square
Trial
plus
version.
z2 minus z1 whole square under root
Trial version.
equals to d. Is it okay? You can write
Trial
it down, the
version.
distance between the two particles. Is it clear?
Trial version.
Is it clear?
Yes, sir.
Trial
Yes, sir.
version.
Now from here you can convert any one coordinate, any
Trial
one out
version.
of 6 in terms of other. So will that coordinate be any more
Trial version.
independent coordinates, sir?
Trial version.
No, sir.
No, sir. So basically that means how
Trial
many
version.
independent coordinates you are getting it, sir? So from 6, 1 gone.
Trial
Sir,
version.
independent coordinates are available when?
So I am telling you the distance
Trial
between
version.
these two particles, same, the fixed constant. Is it okay?
Trial version.
The distance
Yes,
between
sir.
this molecule and this molecule is fixed. So
Trial
3
version.
and 3, 6 coordinates. Okay, so I can make an equation using the distance formula.
Trial version.
Under root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square.
Trial
That
version.
is equals to d. Now, if you do make d, then any one out of 6, any one coordinate
Trial
you can
version.
convert in terms of other coordinates and d. Is it okay?
Yes.
Trial version.
Yes, sir.
Am I right? So will that coordinate be any more independent?
No,
Trial
okay, sir.
version.
So how many independent basically coordinates you are getting it in this system?
Trial version.
5.
5. At the beginning only I told you degree of
Trial
freedom
version.
means number of independent coordinates required to specify the position or configuration
Trial
of a
version.
dynamical system. So
স্যার আমরা
total
কিভাবে
5. Huh?
Trial
স্যার আমরা
version.
কিভাবে বুঝি যে কোনো একটাই চেঞ্জ করতে পারবো আর একটা রেসপেক্টে?
আর একটা কি করে হবে তোমার? একটাই তো
Trial
ইকুয়েশন।
version.
না স্যার, তুমি যে বললে না মানে 5 হবে, তো
Trial
মানে যে কোনো
version.
একটাকে আমরা ডিপেন্ডেন্ট
যে
ধরছি তো?
কোনো একটাকে, হ্যাঁ, যে কোনো একটাকে অন্যের ফর্মে।
Trial version.
So ultimately 6 minus 1 to always then come.
Trial version.
Roop understood?
হ্যাঁ স্যার।
Trial version.
Got it? If you make x2 as
Trial
subject
version.
in terms of other, then x2 will not be there, or x1, anyone,
Trial version.
or y1 or y2, or z1 or z2.
Trial version.
All right.
ইয়েস স্যার।
Now your
Trial
job
version.
for triatomic gas, how many degree of
Trial
freedoms
version.
are there?
Sir, 8.
Trial version.
So triatomic gas,
Trial
how
version.
many?
Trial version.
9.
Trial version.
For triatomic gas, how many?
Sir, I'm confused
Trial
between
version.
8 and 9.
Sir, 8 হবে না?
7.
Trial
You are
version.
saying 7. Warner is saying 7. Anyone else?
Trial version.
Sir, 7.
7. Okay,
Trial
Nandika.
version.
Sir, I think 7 because I can convert 2 into
Trial version.
Sir, 7.
7. Now, in
Trial version.
triatomic gases, there might be the two forms, either 7 or 6.
Trial version.
Okay. So your job is to why 7 or 6 to find it out.
Trial version.
Two
Sir, linear
possibilities are there. Yes, yes. If the molecules, 3 atoms, they are linear, then
Trial
there will be a
version.
7. Because then you will get two independent equation. If they are not
Trial
linear,
version.
9. Non-linear.
then non-linear, then you will get your
Trial
3
version.
independent equations more. That means 9 minus 3, that gives you 6.
Trial version.
If the atoms are linear,
Trial
then you
version.
will get two equations, independent equations, so you can make two,
Trial
I mean you're
version.
dependent on others, so that will be 7. 9 minus 2, 7. But if there are non-linear
version.
all the atoms, that means then you will get it your total, then 3 equations, independent equations, so you
version.
will get it total 7. Is it okay?
Trial version.
Is it okay for everybody?
ইয়েস স্যার।
So our
Trial
kinetic
version.
theory of gas is over. Next we will be doing few sums and then we'll move on to the
Trial
thermodynamics first law. Okay. Thank you very much. Bye bye.
Trial
Take
version.
care. Stay safe. Stay home. This part are all are easy part. So no
Trial
problem.
version.
You won't have any problem.
Trial version.